First, the chair that puts itself together. One of these two chairs is a work of art. Here's a hint. It's not the one with the artist sitting on it.
Chair is in the studio at the moment, and it's soon to be on its way.
Max Dean is packing it up. Now you may be thinking he should pack it in. After all, that chair just fell apart. But that is the idea. This is a robotic chair designed to fall apart and to put itself back together. For Max Dean, it's a metaphor for life.
But we see ourselves in the chair, continually reassembling itself, somewhat like what we do in our own lives. We fall apart and we put ourselves back together.
Max Dean's vision for the chair goes back 2 decades. But while he had the vision, he lacked the expertise to turn it into reality. So instead of building the chair, he built a team. Fellow artist Matt Donovan took on the mechanics.
What's the angle that I'm not trained in engineering. I'm trained as a sculptor and an artist. And so there was a lot of learning that I had to go through.
Cornell professor Rafael Odandria, known to his friends as Raf, served as chief engineer, created the computer programs for the system. And Steve Lowe, one of Dandria's former students, built the electronics to make it run. But the one thing they have in common was that they all started this project from scratch.
We all have one particular trait, okay? The particular trait is that you have to have the ability to start at zero.
Max Dean's original vision was to have a robotic arm on the chair, pick up the pieces and slot them into the base.
There's many reasons why that's not the best way to do it. One of them is the forces and torques involved are much too large. The other one is that if pieces fall far away from the base, it's very difficult to build a long enough robotic arm to actually find them.
Returning to the upright position would also be tricky.
Equivalent of a 2-year-old on Olympic rings doing an iron cross, with their arms stretched out. And of course, it's very difficult for a 2-year-old to do that.
The breakthrough was Raf's. Make the chair seat a robot that could drive around and dock with the pieces, then pull itself up on all fours. Back to the analogy of the kid doing the iron cross.
So what we have right now would be the equivalent of a, say, 8-, 9-year-old to do it. Possible, difficult.
Even with Raf's idea, the forces involved in returning to upright are enormous. Matt had to figure out how to conquer them.
I actually built 6 prototypes to accomplish this, and that's where I did the bulk of my learning, engineering-wise.
The chair seat determines which pieces to grab thanks to computer vision, starting with this camera. The camera snaps pictures and digitizes the information for the laptop. A computer program then decides which pieces should be picked up in what order.
The computer communicates with the chair base and actually tells it what it needs to do, such that it executes the motion in a nice, smooth way.
Raf can follow what the chair is thinking with another program he's devised, a program he calls Chair Thoughts. It helps him determine whether there are any bugs in the system.
As the program is running, if you look at the computer screen, there's actually messages that the chair is sending out, telling me exactly what it's thinking. The chair cannot grab the back if there are 2 legs at the back already. So one of the things that the chair figures out is, if it already has legs, is that it needs to drop them off. So one of the messages is, oh, I need to drop off my legs before I go for the chair back.
There's a lot going on in that seat.
So here we have the chair, and we'll take a look inside. So if you see inside the chair, we have this control board here that houses the brains of the chair right here in this little chip. Right here we have the radio that talks to the laptop. So when the laptop tells us we want to move the chair, the commands get sent through here, they get routed to this brain which interprets the commands, and then this brain sends the commands to the motor drivers section in that area. They're underneath the board right now. And those motor drivers actually turn and run the motors. Other things you'll notice that we have some cables running up. That's for feedback from the various sensors we have on, so we can know if we have a leg or if we don't have a leg. We also have some shock absorption right here, because the chair hits the ground pretty hard and it hits it often. So we have to be able to ensure that we're not going to damage things when it hits.
Beneath Steve's electronics are Matt's mechanics.
One of our main constraints or limits was that everything had to fit inside the chair. We've got 14 motors in there, we've got gearboxes, we've got 2 separate types of drives.
But Max insisted that the chair resemble a regular chair in size and form.
One of my challenges is to maintain the vision of the chair. Well, that's where my role comes in, and I say, no, The chair, like the one I'm sitting on, is got 1.25 inch square legs, and I will go to 1.5 inch leg, but that's as far as I will go.
Because as much as the chair is a robot, it's also a work of art.
The chair definitely has a personality and character. Maybe character would be the best way to put it. Its character is that it's wood nature, for example. It's a very simple design. It's humble in its use of material. It's certainly not humble in what it can do or its capabilities.
Max and his team are pretty proud of their own capabilities now that they've turned their vision into reality.
We've proven to ourselves individually and collectively that we can build something that's of a highly complex nature, that can withstand this constant falling and reassembling like that, and that we can work together in a creative and kind of unique way.